The purpose of this video is to demonstrate for my students exactly what equivalent fractions are and how to create equivalent fractions. The definition for equivalent fractions is fractions that represent the same part-to-whole relationship. They are fractions that represent the same part-to-whole relationship. I have here a couple fraction bars, that we can call them, that I'm using to demonstrate what that really means, to have a same part-to-whole relationship. When I look at this strip here, it is divided into 1, 2, 3, 4 parts. There are 4 possible parts, so that's going to be our denominator. 3 of the parts are shaded in this blue color. So 3/4 of this strip is shaded blue. Now you can tell by how the blue in this strip is flush with the blue in this strip that they're the same amount. This bar is divided into 1, 2, 3, 4, 5, 6, 7, 8 pieces or parts, and 1, 2, 3, 4, 5, 6 of those parts are shaded in blue. So this proves to us that 3/4 is equivalent to 6/8. Now, I'm going to write 3/4 here, and I'm going to put 6/8 over here, and then I'm going to explain a little bit of information that will help make it easier to come up with equivalent fractions without having to actually make the models for it. Whenever you want to make an equivalent fraction, you just simply multiply the numerator and the denominator of a fraction by the same number. Now, it's almost like multiplying the fraction with the same numerator and denominator like this. Let's say, for instance, I have 1/2. Now, if I multiply that by, we'll say, 4/4, that will give me an equivalent fraction. 1 times 4 is 4, and 2 times 4 is 8. So 4/8 is equivalent to 1/2. Now, the reason that this is equivalent like that, I mean, all we've done is just perhaps made the numbers of the numerator look bigger and the number of the denominator look better, but it's still 4/8 essentially is 1/2, is we are multiplying 1/2 by a form of 1. We have already learned in the past that whenever you have the numerator and denominator the same, you have created a whole. For instance, with this situation, 4/4, it would almost be like there are 4 quarters, and all 4 of the quarters belong to you. So you have the whole amount. So here is a whole. Now, let's look back at this one. What do you think was multiplied? What multiplied 3 and 4 to give us 6 and 8? One of the ways we can do this is just a quick little division. 6 divided by 3 would be 2, and 8 divided by 4 would also be 2. So one of the forms of 1 that we used here to get the equivalent fraction 6/8 from 3/4 is we multiplied 3/4 by 2/2. Let's look at another example. Let's say that we have 5/8, and we get an equivalent fraction of 15/24. Now, what was 5 and 8 multiplied by to get 15/24? We can do just a little bit of division on this. 15 divided by 3 is going to give us 3, and 24 divided by 8 will also give us 3. So this form of 1, 3/3, is multiplied with 5/8 to give us an equivalent fraction 15/24. Now, let's make it just a little bit more difficult. Let's say that we have this numerator and with this denominator, 9/12. And let's say that we get the equivalent fraction, but all we're given is simply the denominator 12. One of the easy ways to figure out what goes here, here, and here is just to look at, we have 12 here, what happened? What was 12 multiplied by to give us this 12? And the easy answer is 1. 12 times 1 equals 12. And if that's so, whatever we multiply the denominator by, we have to multiply the numerator by, so that we're going to put a 1 here. And 9 times 1 gives us 9. So that is one way of looking at equivalent fractions. Equivalent fractions are fractions that represent the same part of the whole relationship. To get an equivalent fraction, you multiply the numerator and denominator by the same number. In this case, 2 seconds, in this case 3/3, in this case 4/4, and here we have a numerator of 1 and a denominator of 1. These are all examples of a form of 1. Now, the reason I looked at it this way, kind of reverse engineering, going from one fraction to its equivalent and seeing what they did to come up with the equivalent fraction, is one of the activities that we're doing requires my students to figure this part out, and so I wanted to show them that way. Another term that I want to introduce to my students is this one here, the multiplicative identity property. Now, we have worked with multiplicative identity before. The multiplicative identity is 1, and it simply states that any number times 1 equals the number you start out with, unless it's a non-zero, as long as the number is a non-zero number. Now, the multiplicative identity property states pretty much the same thing. Any number times 1 equals that number, where that number is a non-zero number. I mean, let's look at some examples. Let's say that we have the fraction 1/8, and let's say that we multiply that by, we'll say 2 halves. 2 halves is essentially a whole, or 1. So if we multiply 1/8 by 1, we're essentially going to have the same value as this 1/8. Now, that form of 1 could be perhaps 3/3. And if I multiplied 1 by 3, that's going to give me 3. And if I multiply 8 by 3, that's going to give me 24. So 3 over 24 is an equivalent fraction of 1/8. It has the exact same value. I could draw a bar out here and divide the first one into 8 equal parts and shade in just one. Do a same length bar, divide it into 24 parts and shade in the first 3. And that 1/8 part will be the exact same length as that 3/24 part. Now, let's look at another example. Let's say that we have 4 over 9. I can multiply both the numerator and the denominator by a form of 1, such as perhaps 5/5. And if I multiply 4 by 5, that'll give me 20. If I multiply 9 by 5, that will give me 45. So 4/9 is equivalent to 20 over 45. And the way we got that was through the multiplicative identity property. Even though our numerator and denominator look so much larger than 4/9, the value of this 20 over 45 is exactly the same as the value of this 4 over 9. All right, this next activity, I'm going to write down a fraction. We'll start out with 1/4. Now, I'm going to try to come up with 10 equivalent fractions, the first 10 equivalent fractions that I can, just to show how this works using the multiplicative identity property. When I have 1/4, I would say my next one, I'm going to multiply both the numerator and denominator by 2 halves. So 1 times 2 is 2, 4 times 2 is 8. Now this time I'm going to go with 3/3. 1 times 3 is 3, 4 times 3 is 12. Now I'm going to use 4/4. 1 times 4 is 4, 4 times 4 is 16. Now I'll use 5/5. 1 times 5 is 5. 4 times 5 is 20. This time 6/6. 1 times 6 is 6. 4 times 6 is 24. The next one, I'll use 7/7. 1 times 7 is 7, and 4 times 7 is 28. The next one is going to be with 8/8. 1 times 8 is 8. 4 times 8 is 32. We'll use 9/9 this time. 1 times 9 is 9. 4 times 9 is 36. And our last one, 10/10. 1 times 10 is 10, and 4 times 10 is 40. So all of these fractions are equivalent to 1/4. They're the same value. They're no more proportion than the others. They may look like they have larger numerators and denominators, but they're exactly the same value. Now, I'm going to put just a few more up here and give you a moment to try some of these on your own, perhaps with 3/5, 2/3, and 5/8. Now, I hope that this video has helped clear up a little bit about what equivalent fractions are and how we can create equivalent fractions. Thank you.